Hello, everybody. Welcome to the European Association of Geochemistry Reactions event on critical minerals. My name is Ichiko Sugiyama, and I am currently the chair of the EAG Communications Committee. First of all, I would like to say thank you to everybody who helped organize this event. And thank you, Tanya, for being a speaker today. Unfortunately, due to unforeseen circumstances, Blandine was unable to attend last minute. So sorry about this. As for all of you who are new to EAG Reactions, I would like to quickly give you an introduction on how this event is formatted. We have 20 to 30 minutes of talk, including introduction that I'm currently doing now, followed by 30 minutes of open discussion and Q&A. So before we start, I would like to quickly introduce opportunities that EAG offers. So EAG provides a forum of presenting geochemistry, exchange ideas, publications, recognition of scientific excellence, and more. So in this figure here, we have awards, we have 2 open access communication publications. We also support and help assist in Goldschmidt conferences. We also have funding opportunities for early career scientists and many more things such as outreach, mentoring, networking, and communications. So please, if you want to know more about EAG, please visit www.eag.org. Thank you so much. And let's move on to the speaker. Joanna, would you like to introduce Tanya?
Yes, thank you. Hello, everybody. So I'm very proud to present our speaker for today's EAG Reactions, which is Tânia Martins. She is the Chief Geologist of the Precambrian Geoscience section at the Manitoba Geological Survey in Canada. Original from Portugal, she completed her PhD at the University of Porto, where she specialized in studying lithium, tin, niobium, and tantalum mineralization in granitic pegmatites. After that, she moved to Canada for a postdoctoral research on the mineralogy of alkaline rocks and carbonatites. And since joining the Manitoba Geological Survey in 2011, Tanya has made significant contributions, and as of May of this year, she's taking on a leadership role as chief geologist. So her journey brings a unique perspective, in this case from the other side of the Atlantic, to today's discussions. Thank you, Tanya, for joining us, and the floor is yours.
Thank you very much, Joanna. I appreciate the invitation. I'll start to share my screen and hopefully this goes on good. All right. Can you please let me know if you can see my screen okay?
It's working well.
Okay, excellent. Thank you so much. Yeah, for me, it's good morning. I know everybody from Europe, coming from Europe, will be good afternoon. So, good day, I guess, in general. So, I really appreciate the opportunity to speak to you guys. The European Association of Geochemistry. I really think this is a good initiative. I was reviewing some of the other events, and I think it's really good. It's a really good initiative. So thank you for the invitation. And this during my presentation, I'll be telling you a little bit about lithium, which is considered a critical element for the green transition. And we have seen a lot of attention related with lithium exploration in Canada, particularly related with pegmatites. So Joanna already told you a little bit about my path, my career path, and I just wanted to share some photos and a little bit more information about that. I am originally from Portugal, and I went to Porto University for my PhD, and I spent a lot of time with looking at gorgeous rocks, a beautiful landscape at the University of Porto. Many days working with lithium minerals, and that was a really good experience. The pegmatites are dear to in my heart. Those are definitely my favorite rocks. After my PhD, I moved to Winnipeg. And in Canada, it's also known as winter peg, as most Canadians joke about, so that it's always winter in Winnipeg. It does snow a lot, but it's not always looking like this. So I did a doctoral grant. I was a postdoctoral fellow at the University of Manitoba for a couple of years. And then after that, I switched gears and I joined the Manitoba Geological Survey. And that was a completely different, totally different type of work that I was used to do. The field work was very remote, and most of my projects I have to access the areas by plane, and then we live in tents or in camps. I have a photo here of a float plane on a lake on the camp on the background, but sometimes we do just live in tents in the middle of nowhere with no facilities, and this will be our office. So it's quite high tech, actually, with satellite phones and computers, because technology has arrived to remote areas of Canada as well. And you spend essentially all day long walking around, looking at rocks, and collecting samples. So a lot of the work that I do recently, or more recently with the survey, is related with pegmatites, but I also have quite a bit of experience doing a regional mapping, tectonic interpretations, and that kind of work. So sometimes it's hard work, and you live in a tent for a long time, but you also have opportunities to see landscapes like no other, northern lights, and also activities that honestly I never thought I would do, like fishing. It's a really good experience to have, to do this type of field work. I really enjoy it. So just a little bit about the Manitoba Geological Survey. We are a government institution. So in Canada, every single jurisdiction has their own geological survey. And then at the federal level, there's the Geological Survey of Canada as well. So one of our mandates is to create public and open geoscience information. And this type of information can be used for many things. So it's easy to think about the applicability of our work to the exploration industry, for example. But all of the information that we create helps to reduce public risk. If you think about geohazards and all sorts of information, water safety and quality. And so all of this information helps communities with their land use plan and to know what they have in their land. I'm not sure if my presentation will be shared with you guys, so you can take a look at some of these things in a bit more detail. One of the things that we have in Canada about this public geoscience and having all of our information available for free, it's like it makes us really powerful and attractive to investment. And Canada lives a lot, the economy is based on natural resources. And it's not just mining, but it's forestry, fisheries, agriculture. So that aspect of providing information and making it publicly available, it's important, and it's something that we believe here with the surveys. So now a little bit about Canada's critical minerals list. So this is a list of 34 minerals and elements. And given that we are talking, or the theme of these reactions are critical minerals, I decided to show you what are, or the critical minerals that Canada considers, or the minerals and metals or elements, the way you want to call it, that Canada considers critical. I was comparing them to the European Union list, and there are a few differences. I know for Europe, for example, the critical raw materials list splits the rare earth elements into light and heavy. Another example is the fluorspar, like for Europe, also feldspar is included, for Canada is not. So there are a few nuances on this list, but essentially these minerals and metals are considered critical for various reasons. And now we talk quite a bit about the criticality of some of these elements, and it feels like it's something new. But the reality is different. Like throughout our history, we actually have created these lists to expedite, be it exploration or mining or certain projects. And that would be all related to whatever is needed. So after the Second World War, there was also a critical minerals list, and it would have been quite different, or some elements probably the same, but there would be emphasis on different elements. Right now, we talk a lot about lithium, and that's because we see lithium as so important for the green transition and decarbonization of the economy. And I speak a lot about lithium because I do a lot of work with lithium pegmatites. During the next slides, I'm gonna be talking to you about the Tanko pegmatite, and that's one of the two lithium mines that we have in Canada. Just for those that don't study pegmatites, the Tanko pegmatite is one of the most studied pegmatites in the world, and it's kind of the reference for pegmatite research. So just to bring you back again to Manitoba, to localize you in the map of Canada, Manitoba is this province here highlighted in green. We're quite central in the country. And the location of the Tanko pegmatite is that green square at the bottom as well. So the capital of Manitoba is Winnipeg, and that's where I'm today speaking to you from. And that is also in the south, close to where that arrow is pointing, actually. And the Tanko pegmatite is about two hours northeast of the city. I always like to start by presenting the Manitoba geological map and the location of the different lithium pegmatite fields we have here in the province. And a really quick crash course on Manitoba geology. On the right side, and I'm not sure if you can see my mouse, but I can. Okay, I think perhaps like this is better. On the right side here, we have the Archean Superior Province. On the northwest corner, we have rocks of Paleoproterozoic age. On the northeast and southwest corners, we have rocks of Phanerozoic age. And then the entire province is covered by Quaternary age sediments. You can see on the map that I plotted these yellow stars with the location of the different lithium-bearing pegmatites here in Manitoba. And just another thing about these stars, they don't represent single pegmatite occurrences. So in these fields, we typically have dozens and sometimes hundreds of pegmatites, and they're not all lithium bearing, as typically pegmatites occur in the field with a variety of associations. And it could be association of barren pegmatites, meaning devoid of mineralization, in association with lithium pegmatites, niobium bearing pegmatites. So we can have quite a bit of geochemistry variety within the same field. So by looking at the map, you can clearly see that the majority of the fields are located here on this side in the Archean Superior Province. So the oldest rocks here in Manitoba is where we have the highest lithium potential. And I'm going to be talking about the Cat Lake Winnipeg River. That is the host, that is where the Tanko pegmatite is located. So we're talking about an Archean terrain. Here in Manitoba, we have a bit of a sliver, and then it continues into Ontario and further east into Quebec as well. So the Tanko pegmatite is part of the Bird River Greenstone Belt that is located here in the context of the Superior Province. And this is a combination of a greenstone belt with supercrustal rocks and granitoid rocks. Within this greenstone belt, we actually have a wide variety of critical element mineralization, copper, PGEs, nickel, also gold that might not necessarily be considered critical at this point. And we have a lot of lithium pegmatites. One of the big names in pegmatite geology or pegmatite research was Peter Cherney. He was a professor here at the University of Manitoba, and he studied this area in a lot of detail. As part of this study, he described the Cat Lake Winnipeg River pegmatite field in a lot of detail, and divided the field in many different types of groups. I just zoomed into more of a local regional geology. This is the the geological map for the entire Bird River domain, with the supercrustal rocks represented in green and shades of brown, and the granitoids in pink. Also plotted here on the map are these dashed blue lines, and you can see there are quite a few here in the north and another few here in the south. And these are the locations of the different pegmatite groups that we have in this area. So all of these groups were formed taking into account spatial associations, mineralogical associations, fractionation indices, and things like this. Another thing that I always like to point out when I present this map is that the location of these fields is kind of concentrated along major breaks in the crust. So when we think about major breaks in the crust, we can think about domain boundaries, terrain boundaries, boundaries between different rock types. So in this case, we're looking at a boundary between the Bird River Greenstone Belt, this area here, and the English River Basin. So this is a major shear zone that divides the two domains. So we have two important groups of pegmatites in this area. And then the other major break in the crust is here in the south with the Winnipeg River terrain. And similarly, we have quite a bit of granitic pegmatites as well. And the location of Tanco is here, and there are major shear zones that go roughly east-west in the Tanco area too. Keep going with the geological context, but now more on the structural geology. We know that there has been a series of deformation events and reactivation of these deformation events. And in my view, the role of the structural geology in pegmatite emplacement and pegmatite research has been always taking a backseat. In part just because minerals can tell us a lot of things, and they're so exciting, and that's what people tend to study the most. But the role of structural geology is certainly extremely important to understand how pegmatites intrude, how the emplacement takes place. So I'm actually quite happy that I've been collaborating with one of my colleagues here at the survey that has been studying the structural geology of the Bird River belt in a lot of detail. And I also have a collaborator with the Geological Survey of Canada that is focusing on these the structural controls and pathways and how important these things are for emplacement of pegmatites. So I would encourage you to look for some of these reports if you're interested in structural geology, and I can certainly guide you in that direction if you are interested. Okay, so now let's talk about the Tanco pegmatite a little bit. So I told you this is currently a lithium and cesium mine. And this is an aerial photo, and you can see all of the different offices associated with the mining operation, from like rejects and where the ore is processed, the chemical plant, the core farms, and so forth. And you will see that it looks it's a quite pretty image with the lake, and actually the mine is underneath the lake. So we access the mine through a ramp here, so there's no shaft that we go up and down like a typical mine. So you go down the truck to access the mine. In this idealized mine cross section, this is the old head frame that is now used for ventilation and emergency purposes only. And here is that portal I was telling you about. So you go down the ramp into the mine. And then because of the characteristics of this rock, and I'll show you a photo, schematics of the zonation, but this pegmatite is extremely zoned. And because of that, they mine it selectively. So when they're mining it for lithium, they might go to the lithium area. They need some cesium, they go to the cesium area. So the mine kind of, it works very different than a regular mine that you just go in and scoop everything out at the same time. The mining is a room and pillar method, which means when you go down, you actually see, it looks like a cavern supported by pillars, so hence the name. So they start at the top and then work their way down. They chew away the rock their way down. And some of the older parts of the mine, some of the most mature parts of the mine actually have ceilings that are over 20 meters tall, and they have to use custom designed aero lifts to do the safety or to continue to do the safety of the mine and to access certain areas. The Tanko pegmatite itself extends for about 1 kilometer in the north-south direction, and on the east-west direction, it goes for 1.5 kilometers. At its thickest is about 100 meters, but that's really through the center. It kind of tapers out in a saddle-like shape towards the edges. It's sub-horizontal, and in terms of its age, we have information, uranium-lead ages from Columbite group minerals that give them an age of 2641, give or take. It's extremely well studied, quite a bit of drill hole, over 2.5 kilometers of drill holes. And there's a lot, more than 2,500 drill holes and almost 172 kilometers of recovered core. So lots of information on the pegmatite. I already mentioned it is zoned, so it's quite complex. All of these different colors refer to different mineralogical associations within the zone. So the polysite zone, for example, is this bright blue. And currently what they're targeting are the zone 40 and 50, where most of the lithium mineralization is at. So that's like the lower intermediate and the upper intermediate zone. So it's those orangey colors and these gray colors. In terms of mineralogy, the pegmatite is extremely complex. There's more than 100 minerals described at the mine, and the mine is also the type locality for 2 minerals. These are some photos from underground. And here on the right is a photo of the tantalum mineralization. This chisel is 25 centimeters for scale, so you can see the tantalite crystal is quite large. And this white, this is a barrel, a nicely shaped barrel. The barrel at Tanko is white because of the presence of cesium. This is another photo from underground where the aplite zone meets more of a feldspar quartz bearing zone, and you have the barrel fringe, a typical picture of a texture of Tanko for sure. Another photo from the cesium zone. So we have polysite here and these veinlets of lepidolite coming through. A photo on the right is what is often called spodumene quartz intergrowths. So the interpretation is that these intergrowths are a pseudomorph after petalite. And Tanko is actually classified as a petalite pegmatite, and you very rarely see the petalite. It's been all what you can see now is this spodumene quartz intergrowth instead of the petalite. And then a final rock photo here that shows the contact of Tanko with the host rock. So the host rock is a gabbro that I don't think I mentioned, so apologies for that. Recently, because there's so much interest in lithium, we have some research going on at the Tanko mine, and one of the students that has been working there for a bit, she's now at the latest stages of her PhD. That's Katrina Brisley. She's been focusing on this spodumene and quartz intergrowths at the mine. So the interpretation is that the petalite breaks down through an isomorphic reaction to spodumene plus quartz. So if you do the calculations, you would expect a specific ratio between spodumene and quartz after this petalite breakdown. But what you observed on the ground is actually, it's not consistent. So sometimes you do see nice shapes like the photo I showed you, where it looks like there was a preserved crystal that now is spodumene and quartz, but then other times you don't have the preservation of these crystals. So you have a combination of different textures, and you have a combination of different proportions of quartz and spodumene. So one of the things that Katrina started to do was to characterize all of these different textures and all of different ratios for this spodumene and quartz association. And she came up with a classification and that characterizes all of these types of associations. So on photo A, you can see equant spodumene crystals. And then on C, on the right, the center column, you will see that some of these equant spodumene crystals seem to be taken over by a skeletal type growth. So she named that microsquee. So more than the textures, she used quite a variety of techniques to characterize all of these associations. And she also did quite a bit of work in terms of the chemical characterization of these types of spodumene associations. So she noted that there are different concentrations of manganese, tin, germanium, and there was also some variations between the different textures. So this is work that should be coming out pretty soon, where she addresses the different origins or different potential origins of this spodumene and quartz intergrowths, because we think that there are more possibilities than just the petalite breakdown. So stay tuned. There will be a paper coming out about this. And why is this important? So this is important because it has quite a bit of implications at the production, at the milling stage, and the concentration of the spodumene ore. This is a diagram that Katrina put together, and it represents from the bottom of the mine to your spodumene concentrate all of the different processes that it goes by, and how that information can be so important for the processing. What they do at the mine to separate the spodumene is that they use gravity or density. So they use the natural characteristics of the mineral. So spodumene has a specific gravity of 3.15, so that's quite dense and is easily to separate from a quartz or feldspar that have a density of about 2.6. But now, if you're mining not just spodumene, but a combination of quartz and spodumene, your specific gravity is not going to be for the spodumene that you're taking from underground is not going to be 3.15. It's going to be lower. So it's important to understand the relationship between the quartz and the spodumene so that you can adjust your density media when you're doing your mineral separation. We here at the MGS support a lot of research that happens in Manitoba. Our mandate is to always learn more about the geology of Manitoba, but we use public funds and we have to be very conscientious about how we use the money. So we really like to support the research so that the students and the university professors take it the next step. And I also like with all these projects that they have an applicability to the mine or to the explorer, because it is important to do science, but it's also important to bridge the gap to the real world, if you want to call it like that. So lots of work has been done at Tanko. There's work going on at Tanko right now, but there are a lot of questions that are still unresolved for the pegmatite. You can see a few of them listed here on the slides. I'm always open for more collaborations, and if there are any students that are keen in joining this type of future research at the pegmatite, please let me know. We can always hook you up with another professor and have more work done at the mine. So I really appreciate the opportunity. I like to close with this beautiful photo of Beryl, and this is from the Canadian Museum of Nature in Ottawa, Canada, that I visited this past July. Thank you so much.
Thank you so much, Tânia. This was a fantastic talk. We would like to start having an open discussion, or maybe perhaps go slowly and start with Q&A session. So if anybody has questions, please indicate that you have a question or unmute yourself and start asking. So thank you so much. Anybody have questions for Tânia?
Joanna has a question.
Yeah, so maybe not a question, but to start the discussion a bit. One thing that I found curious, and it was one of our initial curiosities, was would the critical minerals list or the strategic minerals list from Canada, would it be very different from the one that we have here for the European Union, for example? And I was checking when you mentioned 34 critical raw materials or strategic minerals. I thought, oh, that's a lot. And then I went to check the official EU list for 2023. And in fact, they also have the exact same number, which is 34 critical raw materials. So I think that in this list maybe a bit similar. Tânia, can you tell us a bit more about the factors that are taken into account when these authorities are producing these lists?
Mm-hmm. I can only comment not at the Canadian level per se, because I wasn't involved in developing the Canadian list at the federal level, but I was involved in developing our own list here in Manitoba. So currently, what I see that is really pushing a lot of these elements is the trying to not use as many fossil fuels for our transportation, right? So having more of the electrical vehicles and the push for the use of lithium powered vehicles and batteries and things like that. And for that, we need quite a bit of raw materials. Not only we talk about lithium a lot, but actually lithium is a small component of a battery. So we need copper, we need nickel, we need all sorts of, we need vanadium, we need graphite, we need all sorts of components that go into that battery. So so the situation, I'm looking at the critical raw materials for Europe, with the rare elements, for example, we need a lot of those for magnets that are used in wind turbines. So I think the current push, or that what is behind a lot of these elements, is really this transition from the fossil fuels into a more of a renewable energy situation. So for us, when we were looking at the ones that are important for Manitoba, we also look at the economic factor. So gold is not listed in either the European one or the Canadian one, and I don't think for the US or Japan is also, I don't think it's listed either. But for Manitoba, it's important that for the economy. So you always have to. There's many factors for this criticality, but for Manitoba, we also took into account what was important, and in terms of what we are already producing, what is important for our economy. So we also had at the time, initially in 2022, we also had silica sand, and that was not part of the Canadian one, but now it is. They brought silica sand or silicon metal for European Union. I'm not really sure if we say silicon metal 2 here for Canada. I can check it.
I didn't realize
they say silicon metal.
I didn't realize they accounted for economic aspect as well.
For Manitoba, they did.
Yeah, that's really cool to know, because I thought it was only because, we're transitioning to cleaner energy, and that, when you do the budgets, right, how many deposits are available and how many materials we actually need to transition. It's like, especially for copper, for instance, it's like, are we gonna even get there, especially with this 2050 emission deadline that governments have been putting on.
It's quite ambitious.
Too ambitious in my own opinion, but like Yeah. Oh, Adriana, do you have a question?
Second, yes. Yes, I have a question. Yeah, first of all, thank you for the talk. I think it was quite interesting. And I also like how you carefully step aside of the critical minerals term and use more like critical element or metals, because we know that the term is very conflicting. I am at the University of Calgary, so also using the Canadian critical minerals list. I do prefer more the European critical raw materials term. But I was thinking, because yeah, we do need more minerals, elements, metals, and the as you mentioned, the idea of these studies is that you make a link with also with the industry, that at the end these results can be used for that supply. That also needs to be sustainable, that we just don't want to dig more pits, but also to make the most efficient use of everything that we are extracting. So in those lines, I was wondering if, along with the studies, you are also immediately assessing like that efficiency on what would be an eventual operation. If is there any consideration of other elements that can also be used that are in also that critical minerals list, and if you're already considering some aspects for the beneficiation and for waste management.
Mm-hmm. Yeah, thanks for the question and your comment. Yeah, I particularly dislike the term minerals because some of these are elements and not minerals. So I try to be true to what they are. But yeah, so I agree that having a critical raw material is probably more appropriate. But anyway, so that's my comment there. We focus a lot of our projects in geology per se, more mineralogy and regional tectonics and things like that. We don't necessarily have an area that looks into sustainability necessarily. So I currently don't have projects targeting that are based here at the survey targeting sustainability part of the equation, which is very important, particularly when we think about the circular economy and trying to use everything as efficiently as we can, as you mentioned, Adriana. So that's a very good part of the research too. But I am part of European project that is looking into ore beneficiation and how we can make it more efficient without so much waste. And that's a project that I am part of to have the connection happen between industry and between the research group. So that's my role, because I don't have a team that looks into that aspect of the sustainability. But I agree that that's a very important component, and perhaps some of the research that we do can bring that component in. Yeah.
Any other comments, questions for Tânia? Oh, Nicholas?
Yeah, this is Nick Arndt. I'm from Grenoble, University of Grenoble. I've got a question, mainly, first a comment about these critical raw materials. I think the initial classification came from the USGS, and it was the combination of how important the metals were, for the energy transition. So that includes all of these metals we've been talking about. That was one characteristic, and the other one was how scarce they are, how secure was the supply. So you have one classification made in for the US and another one for Europe, and it varies a little bit, but I think they were the main characteristics. But my question is, how are pegmatites explored for in Manitoba and elsewhere, particularly the geophysical methods? What geophysical methods can be used? Do you have any information there?
Yes. Yeah, thanks for your comment there. Yes, on the lists, definitely the threat of the supply chain interruptions, that's one of the concerns for those lists too. Thanks for bringing that up. So pegmatites are typically described as geophysical non-responders, particularly the LCT type. So I actually, working with some clients, they have been using quite a different types of methods to find pegmatites using geophysics, and they don't. It's kind of hit and miss, and for the most part, they don't work. But
Right.
I would say, I would say that one of the things that is very important to use geophysics for is to understand the structure of the crust and to understand where these breaks are, the folding, all of the structural geology, to have that information that can be enhanced. Our field observations can be enhanced by the geophysical aspects. So it is important for those, absolutely. If you are exploring for NYF pegmatites with niobium, yttrium, fluorine category or family, then you often have some uranium mineralization associated with that. So you might be able to use radiometrics for that category. So that's kind of my comments. And I know that Joanna has been doing quite a bit of work with remote sensing for pegmatite exploration as well. And I don't want to say anything incorrect. So if you want to jump in, Joanna, by all means. But yeah, it was interesting. So I was organizing the pegmatite symposium. It was here in Manitoba just this past May. And we had a really good presentation from a colleague from industry. And his title was "Pegmatites are not geophysical non-responders." So
if I could follow up with a more technical question, Fleet Minerals uses ambient noise seismology for exploration, and they got a low velocity anomaly in a pegmatite. And I don't understand this. I don't know, because the minerals should be the same as the enclosing feldspar potassic rocks.
yeah.
And that's the question. Why should a pegmatite be seismically slow? Are they fractured? Is there a lot of pore space? Do you have any clues about that?
It has to be a very different environment, because no, there wouldn't be any pore spaces. And no, I actually don't know. That's a good question. I don't know. I didn't realize that. Where was the study done?
I'll send you a link. It's done in Northern Territory of Australia. And they got this anomaly, and nobody understands it really. So
yeah.
Over a pegmatite. Anyway.
Interesting.
Yeah. Thank you.
Well, yeah, thank you.
Fernando, you have a question?
Yes, hello. So Tânia, thank you very much for the presentation. I would like to pick up on one of your comments that you mentioned about the bridge between, industry and the academia, that the geological surveys. I also think that with society will also actually be a three-way bridge that the geological surveys will be in between. But my question specifically is that if we ever felt that the economic pressure from the industry was bigger sometimes, that you had to kind of give more information to them because of this economic importance, or if you can actually, you have support from the institution to keep the boundaries of what they do for the society, not doing work for the mining industries, for example.
Yeah, it's always challenging. Of course, we're all professionals and obey by ethical principles, but particularly working with the public body, such as a government, we have to be very neutral, and we have to support. I'm not going to lie, of course, there are pressures, because there's always going to be a lobby group that I'm more important because of these reasons, and those pressures have to be. We have to put the pressure back, like we have to release the pressure, because we have to develop things in a sustainable way. So even if the company wants it to happen this way, there are regulations in place, be it environmental or all sorts of regulations, permits, and things cannot go forward without going through those processes. So you can put all the pressure you want, but there are all of these systems in place in the background that are regulatory and legislation that kind of are a break for that. It's like I'm in a privileged position because I don't see those pressures coming my way because I do research and I do science. So I have the freedom to develop my programs the way that I see or something that is becoming important and could be of use for the common public. Then that's kind of how I target my projects as well. Not because an industry told me to, but what we actually do a lot of times is in response to what communities might want. So some communities, if they think they have a lot of potential for this or that commodity, they might come to us and say, we want a study that focuses on this area. So those actually take more priority and they're more important to us than necessarily go and target an industry. So it has to be a middle ground always. But yeah, for sure. Sometimes it's complicated, I'm not gonna lie. But yeah. And also thank you for saying the public awareness, because that is very important. And I think that in general in science is something that we're lacking, is to bridge the gap between what we do and the public. And part of it is because it's so easy for us to speak in geology speak or science speak, and then we forget that this is an acquired lingo that takes us years to develop, and that is not necessarily in common usage by the public. Yeah, I hope I answered your question. I wasn't
sure.
trying to
Thank you very much.
to not answer, but yeah, it can be complicated.
Thank
Gerhard, you have a question?
Yeah, thank you. It's a question and a comment. I start with a comment, and especially because Nick Arndt is here, because he was co-author of a paper in 2017 where they looked at data that showed that worldwide, the expenditure for exploration, 30% of that goes to gold. And obviously, gold is not a critical mineral or critical element, of course. And I think this is weird. And the question is, do you see any change in Canada? Canada is a big country producing lots of different minerals and elements and resources. Do you see a change that there is more focus, maybe even politically driven onto the really critical resources? Or is it just the same, that a third of all the money for exploration goes into gold?
Yeah, no, it was a tough. So gold exploration took a big hit in the last couple of years. All of the money was directed to lithium for the most part. So we saw a huge increase in lithium project exploration, and we saw that all of the typical explorers, gold, copper, nickel, they couldn't raise funds. If you just had to wave a flag, and this is not a criticism to how industry works. It's just an observation from my side. If you waved a flag and said, I have a pegmatite, you would get $5 million. You didn't have to say my pegmatite has lithium. They would just give you money to explore, because there's a bit of this disconnect too between what does a pegmatite mean. Like, we know that not all pegmatites are mineralized, but that information might not be with the decision makers or the company owners or the CEOs. So there was this disconnect of so much money being poured in pegmatite exploration, drilling blindly. It was actually really sad to see. But this is also part of how the market cycle works. So if the money is there, companies have to use it, otherwise it disappears. So a lot of my colleagues that were in gold exploration, they could not raise funds for the last 3 years. It was really difficult for them to raise funds. And now things have reverted again. So it changes really fast too. But yeah, so I was just attending a conference these last 2 days, like exploration and government conference, and you could tell that the gold is back again. Gold and copper, nickel are back.
Nobody needs so much of the gold. And now my comment, I mean, you mentioned briefly circular economies and these things, and this really implies the technology of recycling of materials. Now, I made a very simple calculation what recycling could do for us in a world where all the needs, the projected needs for critical materials is increasing exponentially. I mean, you know a lot about lithium, but this is true for all the rare earths. This is true for nickel, and nickel exploration goes all into the nickel laterites with all additional problems there. But anyway, I found in a very simple calculation, and this was then substantiated in a paper by Wesselkamper et al. In 2023, in an exponentially growing research demand, recycling will help you only until maybe 50 years ago, and that is clearly for lithium. So the result is that you get the break-even point of 80% recycling within 50 years. So for the problems that we have now, recycling is needed for the future, but it's not the solution for today.
Mm-hmm. Yeah, no, the recycling aspect is very important as well. And there are certain countries that do invest a lot more in recycling research, like Japan is one of them. Japan is almost devoid of natural resources on its own, but that's one of the reasons that they do so much research and invest so much in recycling technologies. So yeah, I agree.
Are there questions or comments from anybody here? Actually, I just want to say, talking about recycling, Geological Survey of Canada in general are looking for alternative critical mineral resources now. They have recruited like something like 12 people recently trying to look into that problem, like looking at all sorts of different material, not just recycling or increasing extraction efficiencies, I think, but also looking at brines, clays, muds. Like they were like throwing out any material that could potentially we can use to actually obtain like any resource, raw materials as much as possible. Yeah. But I think we only just scratched the surface of that in the last year or two. So I guess we wouldn't find out in the next 10 years if there's anything new, right?
Absolutely. No, that's a really important comment, I think, because we look at like the mine waste as waste, for example, but I think we have to start looking at more of these materials and what kind of other secondary elements can we obtain from that. And I know I saw that Claudia was in the call earlier. I don't know if she's still there, but I know like she's been working with me in a postdoc, as a postdoc in a different pegmatite project for rare earths. And I didn't know that she did some research of using some of these materials, such as chicken poo. So that was like, oh, that's really cool. Because I think we have to open our minds and look at some other products that we consider waste and don't know what to do with them. And perhaps do some beneficiation or investigate at least if there's any potential. Yeah.
Claudia, do you want to say a few words about this?
So my research was mainly on secondary sources. I work with coal ashes, with ashes from manure, as Tânia said. I think in Canada you have a lot of resources. That's why you don't think a lot of using secondary sources. But at some point, it will need to change. So I am here. I can help, and I hope to help.
That's really cool. Awesome. Any other questions or comments from anybody? If not, let's thank Tânia for giving this fantastic talk, and thank you so much for doing this, and thank you everybody for coming.
Thank you so
Tânia,
much.
Yeah, thank you. Do you want to come back to the chat and chat with us after the EAG? Yeah, cool.
Okay, thank you.
Thank you.
Bye, everybody.
Bye-bye.